Okay, so let's talk about matrices. So, by the way, if you guys don't know, matrices is for plural for matrix. So, matrix if it's a singular, and matrices if there are a lot. Matrices if there are a lot of matrix. Okay, so why do we need to use matrix in the first place? Um, it will be used when you are gonna do programming and a lot of maths in when you're doing high level maths, and it's okay if you don't know the usage of it, um, but now you need to know how to represent a table in a matrix. So the matrix, right, it consists of rows and columns. So just like how a table look like, if this is a table, and let's say all of these contains some category, and all of these contain some category too, and these are the datas. These are the datas. So the the matrix, which can be written as a square bracket or also as a normal bracket, will only store the data, so it won't store the category. So just like how in the table it has rows and it has columns, right? You do the same thing inside the matrix. So in this case, let me use a pen. Okay, in this case, um, these and these and all of these are the data. So this is how data is represented in the matrix. Just like how you write the data in the row and the column, and this is how you write in the matrix. And that's all you have to know about how to represent um, data in the matrices. Okay, so let's see this, right? In this case, there are only one row. So the matrix will just look like something like this: 177, 2100, 2000, and 1800. And that's all. It will just have one row, the matrix. And this is also considered a matrix too. And let's see another example. Okay, let's see number C. So the C, in test 1, Samad scores 76 marks for Bahasa Melayu, 82 marks for mathematics, and 72 marks for history, while Hamid scores 80 marks for Bahasa Melayu, 88 marks for mathematics, and 70 marks for history. So if I write this in a table, it kind of looks like this. So mathematics, and before that BM, mathematics, and then sejarah or history, and that's all. And here I will write the names, so Samad and Hamid, and then you can write the score: 76, 82, and 72. Here it should be 80, 88, and 70. So if I write this in the matrix, I will only take this part, which are the data, and if I write that, let's say we use this bracket, we'll just write 76, 82, 72, 80, 88, and 70. So that's how we represent data in a matrix. So now let's say you have a matrix, right? So let's say this is the matrix. We can write an order for this matrix. What is an order? Order is a way of representing the matrix. So it kind of tells some of the information of the matrix. the info that they talk about are the number of rows and the number of columns. So the way you write it is basically you write the number of rows and then times with the number of columns. So here the number of rows is 2. So 2 times and 3 columns, right? So it's just 2 times 3. And you can write these in a sentence. So in the sentence you write matrix 2 by 3. So the two words that you have to memorize is basically matrix and by, and you just insert these numbers 2 and 3, and this is called the order of the matrix. Okay. Another thing is usually whenever we write a matrix, we need to give a variable. So if I say 16, 5, 18, 10, 11, and 4. So this is a matrix. I know that, but we need to give a letter to represent, because let's say there are two matrices, right? Like this matrix, and there's another matrix which is 1, 1, 2 true, and so there are two matrices, and how will you identify which matrix? So you kind of need to give a name to each matrix, right? So that is what we call the variable, and these are the names that you give to the matrix. So whenever we want to call this matrix, you just give me the value from A, matrix A, something like that. And then let's say I want this particular element, so this particular number. So what will I do? Usually, by the way, the name that is given here will be capital letter. And if I want to access one single element, I will use the small letter of the alphabet. So since I'm using A here, I will tell A, and then I will write the subscript, which is the rows times the J. But usually you don't write the times, so you just write A. Let's say you want to access 10, right? 10 is a row 2, and then column, which column is it now? Column 2. So you will tell A22, and that's how you access 10. So A22 is 10, and here B row 1 and column 2 is 2, and B row 1 and column 1 is 1. Okay, so that's all. And from here, okay, let's see this example. So it is given three matrices. Okay, determine the order of each matrix. It's pretty simple. Here there are one row, so 1 times by 3 columns, that's all. Here got 2 rows, so 2 times there are only 1 column, so 1, that's all. Here got 1, 2, 3, 4, so 4 rows times with 1, 2, 3, 4, 4 columns. And then here, okay, actually the element at the first row, third column, P13. So basically they're asking P13. So P, the small letter, so here this is the matrix they are referring to. So the first row, third column is 9, and it's 9. And let's look at this question. The third row, fourth column, basically that means R 3, 4. So third row and fourth column, which is 1. So here 1. Okay, and it's kind of same here. Let's see if they have something new. Well, actually, let me zoom a bit first. Okay, so here they're asking us to access this element, and then you plus with this element. It's pretty straightforward, right? First row, and then second column is negative 16. Then you plus with second row first column, which is 20. So you'll get 4. Okay. So how to determine whether two matrices are equal? Okay. By the way, before I go to this part, if a matrix have only one column, so it says 1 to 5, so it's got one column, one row and 3 columns. So this is called row matrix, if I'm not wrong. Actually, let me make sure it's right. Yep. So if you have only one row, it's called a row matrix. If you have one column, so if you have something like this is called column matrix. Column matrix. And okay, just I'm going to use this. So if you have a matrix like this, so what's the order of this? This is 3 times 3, right? So if you have same number, it will kind of look like a square. So the side of this is kind of the same length. So that's why it's called square matrix. And if it's not a square matrix and not a row or column matrix, then it will be a rectangular matrix. And rectangular can be like this or like this, right? So that's why this is called a rectangular matrix, and this is also called a rectangular matrix. Okay. Yeah, how to determine two matrices are equal? It's kind of simple. Basically, you look at two matrix and see if two things are same. They might ask in exam like how to tell two. When you see both of these things, you know that it's same or not. But if it's not, then you need to tell what are the reasons. So there only can be two reasons. Two matrices not cannot be equal. So first reason is the order is not same. Okay, let's say if two matrices should be equal, then the order will be same. And if they are equal, then the elements or the corresponding elements will be same. Elements will be same. And these are the only two requirements for two matrices to be equal. So let's see these examples, right? Okay, in this case, the rows here is 2 times 2, so 2 rows 2 columns, and here is 2 times 2 2, so both are equal, so the first order is same, so the first requirement is correct. And now the corresponding elements will be same too, so 2 will be equal to 2, and 11 will be equals to 11, and 1 equal to 1, 3 equals to 3. So that's why these are equal. Let's look at the second one. In this case, how many rows are there? 1 and then 2 columns. Here there are 2 columns with 2 rows and 1 column. So the order is not same, right? So it's straight away is considered not equal. The matrices are not equal. So let's look at the C. Now the orders are same, 2 2 2 2, but the values are not same. So you might tell, well, at least all the value here like 8 3 0 negative 7 are contained here too, right? But the arrangement of the numbers should be considered too. So it's like you need to check 3 equal to 3 or not. So it's kind of need to be exactly same. So that's why these matrices are not equal. Okay, the final one. First of all, let's see the rows and columns. So there are 3 rows and 2 columns. Here, so there are 3 rows and then 2 columns. So the order is same. Now the values 0.5 is 0.52, but just in fractional form. This is 6 and 6, negative 1, negative 1, negative 2, negative 2. 0.8, and if you change that to fraction, you'll get 4 over 5. So 12, 12. So these matrices are equal. Okay. If it is given the matrix P and matrix Q like this, and determine the values of X and Y if P is equal to Q. It's pretty straightforward. Like if you write the matrices to look like this is equals to 50 y plus 1 to z. So let me change some colors. Okay, so if you look at here, these must be same as this, right? So you can straight away tell x is equals to 5, and these should be equals to this, right? So you can straight away tell y plus 1 should be equals to 7, and now y is equals to 6. So you got the value of 5, x and y. And now this, so 2z, which is this, must be equals to this, 5 minus 3z. So if I do the algebra, I'll get 5 z equals to 5 and z is equals to 1. So it's pretty straightforward and simple. Okay, let's move on. Okay, there are some basic operations on matrices. Let's see, let me. Okay, basic operations on matrices. Okay, there are three things that you have to know. You can do plus and minus and then multiplication. These are two operations that you can do between matrices. So the first is uh, okay. The first is adding, right? Adding. So adding, subtraction, or yeah, actually only adding and subtraction. When you're doing adding and subtraction, the order of two matrices should be the same. So let's see. In these cases, the rows are 2 and you multiply with 3. Here is 2 multiplied by 2, right? So it can't be added. Like you can't do any addition to A and B. Why? Because if you have 3, right, then which element here you will add on? There's no elements here, so that's why you can't do the addition or subtraction. Here there are only one. The order is 1 2, and here's 1 2, so you can do the operations. Here is 2 1, here's 2 2, so you can't do the operation. And then here you have 2 2 and 2 2, so you can do the operation. Okay. Okay, let's do a simple one. Okay, they want a plus C and D. That's the first question. So what do? We put the value of the C here and then the D here, and then you add the corresponding values. So you add 10 with 14 and you'll get 24. You take negative 8, you plus with negative 2, you'll get negative 10. And then 4 with 1, 6 with negative 3, negative 1 with 5, 7 with 9. And that's how you do the operations. Okay. These if you guys can figure it out, then it's okay. If you can't figure it out, it's pretty simple and straightforward too. You add this with this and then you get this. That's what the question is telling. And now you need to find x and y. So if I write like this, I can focus on creating that equation. So 2x minus 1 minus 1 plus with x, you will get 8. Then just by doing this, you can straight away get the x value, which is 3. And then you look at y. So here we got one y, and then you add this with this. So you must get 5 plus 2y, and that is equals to 13. So here you'll get y equals to 4. So it's pretty simple. So you need to write this as a separate equation, because I'm pretty sure they have marks just for writing out this equation. Okay, let's go to the next one. This is pretty simple. Just if you take f, and f must be a matrix, because you can't add one number with a matrix. You need to add a matrix with a matrix. So just do it as a regular algebra. So you take this and then you plus here, and then you take this and then you minus here, and that's all. You'll get f. And that's what they have done here. They take negative 2 or 3, I mean negative 2 and 3, and then they minus this and then they plus this. Okay. All it's kind of easy. Okay, let's talk about scalar multiplication. There are two types of multiplication you can do with matrix. First is you multiply a matrix with a matrix. You multiply with a matrix. Or you can take a matrix and you multiply with a number. A number. So the number can be 1, 2, any integer. It can be any number, negative, it can be a fraction, or it can be anything. But you don't multiply with a matrix, you multiply with a number, and this is called scalar multiplication. So scalar multiplication. Okay, so let's look at an example. So if you look at here, you have a matrix, right? So this is the matrix, and they're asking you to multiply it with a number. So this is a number, it's not a matrix. So what you'll do, you take the number and multiply with every single number, and this is how you do scalar multiplication. So if you do it, you will get the value. And the same goes to fractions. No matter what you've been given here, you need to take it as a whole number. So since a negative 1 or 2, right, that means you multiply this whole number with every single element here. So that's how you'll get the answer. So okay, so that there are some laws. I'm not really sure they're gonna ask you in the exams or not, but basically commutative law. Okay, there are a lot of laws in maths, right? So one of the law is commutative law. So what do they mean by that? Well, it's basically that a plus b must be equals to b plus a, and if you change the operation, then a minus b must be equals to b minus a. And now you're gonna check, does matrices obey commutative law or not. So if I use just an integer, if I take 1 plus 2 with 2 plus 1, obviously both are same values, right? You'll get 3 equals to 3. So adding integer numbers obeys commutative law. But does adding two matrices obeys commutative law? Well, they do, because adding matrices are basically like adding integers, so they do obey commutative law. But do they not do they obey the subtraction of matrices obey commutative law? Well, they don't. If they ask in exam why or show that it doesn't obey commutative law, then you need to do an example. So you create two matrices like 1, 2, 0, 0, and then here you create 1, 1, 0, 0. So you need to do A minus B, and then you will get the matrix, which is, actually let me do it. So 1 minus 1 is 0, and 2 minus 1 is 1, and 0, 0. And then you need to do for B minus A too. So B minus A is 1 minus 1 is 0, 1 minus 2 is negative 1, and 0, 0. So this thing is not equals to this thing, because here is positive 1 but here is negative 1, so it does not obey commutative law. But if you do A plus B and then you do B plus A, then you will find out that both will be same. So that's how you kind of like prove commutative law, prove that it obeys or not obey commutative law. So distributive law is where it's actually, this is the law when if there's a addition or anything, like let's say you do A plus B, it can be A minus B also, doesn't matter. But if you multiply this with a number like H, this must be equals to HA plus HB. So in matrices, if you use plus or even minus, this will be the result. So the addition and subtraction of matrices does obey distributive law. Okay, all of these are kind of common sense, but if they ask to prove, then you need to give examples of two matrices and you need to do it, actually do it, like actually plus and actually multiply things, so that you can prove that this happened in real life. Okay, now associative law. So associative law is basically something like, if I take three numbers and then I add, right, and thus doing these first and then plus you add with C is equals to when I do this first. So if I do this first and then add C, does that equals when I do this first and then add with A? Well, yeah, because it's adding, so it doesn't matter which one you add first. But if you do subtraction, right, if you do A minus B minus C, and if you try to actually do it, you will realize that it won't be equal. So if I create A, B and C matrices and then I actually do this, I'll find out that it's not equal. So I can tell the addition of matrices obeys associative law, but subtraction of matrices does not obey associative law. And that's all about all the laws. And if all the elements in the matrix contain 0, if all the elements are 0, that means it's called zero matrix, just so you guys know. And then, by the way, if I add a zero matrix with any matrix, I will get the same matrix, because obviously if you take 1 and you plus with 0, you'll get 1, right? Or you take any variable, you plus with 0, you get 0. Same goes to subtraction. Okay, so let's look at this. Okay, you get two matrices, and you need to do this operation. Oops, I think razor. Okay, so I need to do this operation. So this is kind of same as distributive law, right? So this is an example of where I'm going to use the distributive law. Since I know it obeys distributive law, that means if I try to expand this thing, then it will become 3p minus 3q. And you can do this way, or just do the subtraction and then multiply by 3 also can. As long as you get the answer, it doesn't matter. and that's what they did. Actually, they did this thing. They didn't expand. Okay, let's go down. It's the same thing, just involve some algebra, and that's all. Here you'll get one equation and another equation, and then you'll get the x and y value. And if you get something like this, right, so for r equals to one matrix, you just take this and then divide that, so it will become 1/4, and 1/4 will be expanded or kind of like implemented on every single element. So negative 12 of 4 will become -3, and 4 of 4 will become 1, and same goes to 8, and same goes to 4, just so you guys know. And then this is kind of like a example question. So this is the data. Calculate the number of parks at the parking area in a week. Okay, let's actually read the question. The average number of vehicles per day in a parking area for 5 working days is represented in table X. Table Y represents the average number of vehicles per day on weekends. So calculate the number of vehicles parked at the parking area in a week. So this basically is for weekdays, and this is basically for weekends. And obviously there are 5 weekdays and there are 2 weekends. First, you represent this in a matrix, so 42, 20, 8, 11, and then represent these in a matrix. You will get 25, 12, 5, and 3. So if they ask what's the total number of vehicles that is parked in a week, right? In a week there are 7 days, so there are 5 weekdays and then 2 weekends, and then you just try to add these both things, and then you will get a matrix. And now you can get this value, which are covered car, covered motorcycle, non-covered car, and non-covered motorcycle. Okay. Okay, so I've already told you how to multiply a matrix with just a single number, or it's called a scalar multiplication. What if you got two matrices and then I ask you to multiply those two matrices? Well, okay, okay. For this, let me make it bigger. Okay, let's say A is equals to 1, 2, 3, 5, and B equals to 1, 1, 2, 2. Okay, let's say I want to multiply A times B, right? So multiply A with B. What I'm going to do, I'm going to write A 1, 2, 3, 5 here, and then I'm going to write B here 1, 1, 2, 2. Okay, simple, just writing. And the second one, the B, I'm just writing above, just writing at the top. And now I'm going to create some lines. Okay, simple. And now what I'm going to do, I'm going to multiply this with this. So 1, then multiply with this and this. So plus 3. Okay, same goes here. So 2, 1. So you'll get 2. So 2 times 3, you will get 6. So you plus 6. Same goes here. 1 times with 2, 2 plus with 1 times 5, you get 5. Here 2 times 2, you'll get 4, plus with 2 times 5, which is 10. So if I do this, you'll get 1 plus 3, 4, 8, 7, and 14. So this is the multiplication of two matrices. So there are some rules. If there are some rules that two matrices need to follow if they have to multiply. If I need to multiply A times B, then I need to find the order of A and order of B. So let's say the order of A is 1 times 2. The order of B doesn't have to be same exactly like this, but it needs to have the same number as this number. So the column of A should be same as the row of B, or the row of B must be same as A. And here it can be anything, it can be 100 also, it doesn't matter. But these numbers, these two numbers must be same. So it can be 100 times 9, but here must be 9 times 1. Doesn't matter. As long as these numbers are same, then it's good. But if these numbers are not same, even though these numbers are same, then you can't multiply. So 1 times 1, but here is what, 9 times 1. Even though these numbers are same, it doesn't matter. These numbers should be same in order to multiply. Okay, that is what we need to see for multiplication of two variables. Okay. Okay, let's actually do F and G and then G with E. So G is 4, 3 and E is 5, -4, -1, 8, 0 and 7. By the way, if you want to check, G is 1, 2 and E is 2, 3. So 2 and 2 both are same numbers, so they can multiply. So here there are no lines to create because it's the only row, so I just create some lines here. Now you just times here with this, so you get 20 plus -12, and here you get -1 times with 4, you get -4 plus 24, and you take 0 and multiply by 4, you get 0 plus 7 times 3, which is 21. So if I do this, I will get 20 minus 12 is 8, -4 and 20 and 21. So this is the first matrix answer, and same as this. So FG, -2, 7, then 4, 3, right? So I'll create a line here and then I'll create a line here. By the way, this is the matrix. So I just times. So 4 times with -2 you'll get 8, 3 times with -2, -6. Here you'll get 28, and then here you'll get 21. Okay. And by the way, if they tell L square, it basically means L multiplied with L. It's the same thing, just the normal multiplication, but if they square, just multiply with the same thing. Yeah, kind of all are same. Okay, I'm going to stop the video here and then I'll continue in the next video. Thank you.